graph a polynomial with the following features. Has real coefficients. Sorry, not graph. Find a polynomial with the following features. Has real coefficients. C equals 2i is a 0. Negative 1, 0 is a local minimum. And the leading coefficient is 117 times x to the fourth. Yikes. Okay, so where to start here? This first statement seems a little innocuous, like, okay, it's got real coefficients, but how does that help? Well, it's immediately connected to this next idea. These two are coupled together because so let's see here. If real coefficients and c equals 2i is 0, then c is equal to 0 plus 2i, and that implies that c bar, the conjugate 0 minus 2i, is also a 0, as they must occur in conjugate pairs. Let me actually move this. Duplicate. So now that we have 1 0, we have 2 zeros. So x equals plus or minus 2i are zeros. The next piece of information we have is the fact that negative 1, 0 is a local minimum. So what does that mean? Well, as far as a little graph is concerned, negative 1, 0 being a local minimum would mean that it would have to come down and touch that point and go back up. That means that we have multiplicity that's even multiplicity there. But that idea, coupled together with the fact that this is degree 4, since this is degree 4, we have a total of 4 zeros. So c equals plus or minus 2i is 2 of them, which means we need 2 more. That, together with the fact that this is even multiplicity, means that x equals negative 1 is a 0 because it's on the x-axis, and when we plug in negative 1, we get out 0. And since it has even multiplicity and we only have room for 2 more, it must have multiplicity 2. So by the factor theorem, this polynomial has to be x minus 2i, x minus negative 2i. Let me move this down a little bit.
I'm confused as how you got negative 1 for one of the zeros.
Okay, so right here it says that negative 1, 0 is a local minimum.
Okay, gotcha.
Is that okay? Yeah. So this has to, because the y coordinate is 0, it has to be on the axis. Yeah, for sure. You're probably not the only one who was confused by that. So let me just explain it a little bit further, right? So since the y-coordinate is 0, it has to be on the x-axis. And if it's on the x-axis, it's an x-intercept. And if it's an x-intercept, it's a 0, right? So there it is. And then this also has to be x minus -1, but it has to be multiplicity 2, which means that it has to occur twice. So this is multiplicity 2. These are conjugate pairs. But when we multiply, so if we simplify that, that's x minus 2i, x plus 2i, x plus 1 squared. But if we multiply that all the way out, it's only going to have a lead coefficient of 1. And so this last bit here, let me just get a different color. We need to scale this up by 117. Just so it has the proper coefficient. And then, of course, we could multiply all this garbage out, although I don't know that that's strictly necessary. This is 117. This is x squared plus 4. And this is x squared plus 2x plus 1, which is 117 times x to the 4th plus 2x cubed plus x squared plus 4x squared plus 8x plus 4, which is 117 times x to the 4th plus 2x cubed plus 5x squared plus 8x plus 4. And I'm not looking forward to this arithmetic, but let's see. 117x to the 4th plus 234x cubed plus 585 x squared, and then 8 times 7 is 56. Carry the 5, 8, 13. Carry the 1, 936x plus 8, 6, 4, something like that. Gross. Not sure why the book chose 117 just to make it ridiculous. But that's the polynomial with all of those features. I wouldn't worry too much about that last step. I would totally accept this on a quiz or an exam. The rest of that's a waste of time, in my opinion. But my opinion doesn't carry much weight.
Can you screw up just a little bit?
Totally, dude.
Thank you.
Yeah. So that's a good kind of graphing problem to put on a quiz or an exam where I don't require you to factor everything and then graph it in case you make some kind of small error. Your final grade on that problem isn't based on the fact that you made some small mistake early on. Okay. One more example, then we'll take a break. Okay? Okay. Can I scroll yet? Let me know when I can scroll, bro.
You're good. Thank you.
You're good. You are. Okay. Example, what are we on now? Example 6? Oh my gosh.
Yeah.
They get so big so fast. Example 6. Factor f of x completely over the complex numbers. F of x is equal to 2x to the 4th plus 5x cubed plus 13x squared plus 7x plus 5. And we get a hint. Hint. Negative 1 plus 2i is a 0. So I just gave you one of the zeros. How many zeros are there total?
4.
4, because the degree is 4. Can you give me another one right now? The answer to that question is yes, but do you know what it is?
Is it
Negative 1 minus 2i.
It's negative 1 minus 2i. Why?
Uh,
Use your words.
conjugate thing, right?
oh,
Yes,
conjugate
that's true.
pairs.
The word is conjugate, but why do they have to occur in conjugate pairs? Are we guaranteed that they're always going to occur in conjugate pairs?
Yeah, because the i's disappear when they're multiplied.
Right. So what about this statement of this problem is going to ensure that the i's disappear when you multiply out the factors? Okay, I'm going to help you guys out. What kind of coefficients are these?
Real.
They're real coefficients. And if the polynomial has real coefficients, then the zeros occur in conjugate pairs. So that's the articulation that you're looking for there in that statement. So let me do this in red here, since it's part of the solution, man. Real coefficients. So zeros occur in conjugate pairs. So if x equals negative 1 plus 2i is a 0, then so is x equals negative 1 minus 2i. So now we have 2, which means there's only 2 left to find, although we're supposed to factor it. Now, you guys ever read Choose Your Own Adventure books as a kid or as an adult? Oh my gosh. Choose Your Own Adventure, anybody?
No.
No? I have an adult choose your own. Well, I got to be careful how I say this. It's not an adult choose your own adventure. It's not like there's hookers and Coke and or anything like that. But it's an adult choose your own adventure because it's actually called Lose Your Own Adventure. It doesn't matter how you read it. Kennedy dies. Nothing. Man, these jokes go over so much better when I have a live audience. It's not actually a joke. I actually have that book. Any way that you read it, President Kennedy dies by some conspiracy theory. And so the different endings are different, like you get killed and he gets killed by the mob, or it's the LAPD, or, things like that. Anyway, I need to erase all of this from the video. Anyway, I say choose your own adventure here because there's 2 ways that you can go about this. Now, yesterday or the day before, I think it was Adam, you were asking me about what's better and when should I use it, synthetic or long division. Was that you, Adam, we were having that conversation about?
I don't think so.
Oh, well, maybe it was Nathan. Are you here, Nathan? Was that you?
Yeah.
Okay. So we have our choices here. So, let me show you what I'm talking about. If we use synthetic division, then what we have is the following coefficients: 2, 5, 13, 7, 5. But what 0 do we have? Well, now we have to do synthetic division with a complex number, and it'll totally work. But this is the 0, and that's what has to go in the crook here. Let me space these out a little bit. And that'll look like this, right? We'll bring down the 2, and then we'll multiply by 2, and this will be negative 2 plus 4i. Now, don't forget that this is actually 5 plus 0i. And when we add these together, we add the real parts, and we add the imaginary parts. So that is 3 plus 4i. And then we multiply, and this is going to be a little bit more work, right? Negative 1 plus 2i times 3 plus 4i is negative 3 minus 4i plus 6i plus 8i squared, which is negative 3 plus 2i minus 8, which is negative 11 plus 2i. So this is now negative 11 plus 2i. This is 13 plus 0i. We'll add those together and we'll get 2 plus 2i. And then we have to multiply negative 1 plus 2i times 2 plus 2i. And that's going to be negative 2 minus 2i plus 4i plus 4i squared, which is negative 6 plus 2i. And maybe you've already decided that you don't want to do it this way. But this is then 1 plus 2i. And then as we multiply these last two together, we actually get negative 5. And this is 0. So how did I do that last one so quick in my head? Well, that last one was negative 1 plus 2i times 1 plus 2i. And if I factor out a negative 1, this is negative positive 1 minus 2. Oh, come on. Minus 2i times positive 1 plus 2i. And these are conjugates. So this is the sum of squares, which is negative 5. And that's how I did that so quick in my head. And then we get 0. Now, what does that mean? It means that f of x is equal to x minus negative 1 plus 2i times, let's see, this is my remainder. This was constant. X squared, x cubed, 2x cubed plus 3 plus 4i x squareds plus 2 plus 2i x plus 1 plus 2i as my constants. And that's how that factors. And we're unhappy with that. And now what you can do is you can take this and you can do your synthetic division with your other root. Negative 1 minus 2i is also a 0. And now your coefficients are 2, 3 plus 4i, 2 plus 2i, 1 plus 2i. And you can do the long division or synthetic division. Now, and this continues. And I'll do it if you want, but or you can choose a different path. I'll do this in a different color. Since both negative 1 plus or 2 minus I are zeros, then x minus negative 1 plus 2i and x minus negative 1 minus 2i are factors of f of x. But when we multiply this out, this is x plus 1 minus 2i, and this is x plus 1 plus 2i. And when we FOIL this out, we get x squared plus x plus 2ix plus x plus 1 plus 2i minus 2ix minus 2i minus 4i squared. So what I just did there was I took the first term and I multiplied it by each one of those in the second polynomial. And then I did the middle one. And then I did negative 2i times each one of those and FOILed it out. Now, for those of you who have maybe never done a lot of foiling like that, another thing that you can do is the following. So please pay attention here. Or this is x plus 1 plus 2i, and this is x plus 1 minus 2i. And what you do is you make a little grid here, tic-tac-toe style. 1 square for each term horizontally and vertically. And then you fill this out where each position is the product of the row and column that it's in. So that first one is x times x. The second one is x times 1, 2ix, x, 1, 2i, negative 2ix, negative 2i, and negative 4i squared. That way, you don't accidentally miss a combination. We should have a total of 9 terms, and we do. And as we collect like terms here, oftentimes you can collect like terms along the diagonals. And as we collect the like terms, this is equal to x squared plus 2x. These two cancel. We get plus 1. These two cancel. We get minus 4i squared, which is x squared plus 2x plus 1 plus 4, which is x squared plus 2x plus 5. So, since, let me scroll up so you can see this here. Since both x plus 1 plus 2i and x plus 1 minus 2i are factors of f of x, so is their product, x squared plus 2x plus 5. So x squared plus 2x plus 5 divides f of x evenly. But unfortunately, while this has a bonus of it doesn't have any complex values in it because we combined our conjugate pair of zeros. So Bont Pro, no i's, con, it is not x minus c, and we can't use synthetic division. So long division. And so Nathan, in terms of which one do I want to use here, actually it boils down to how complicated you think this complex synthetic division is versus long division with real numbers. Yeah? So we have, x squared plus 2x plus 5 divides into, I don't even remember what the polynomial was. It's been so long now, I don't remember. And we get started. X squared times what is 2x to the 4th? Well, that's going to have a 2 and another x squared. And then we multiply and we get 2x to the 4th plus 4x cubed plus 10x squared, parentheses, subtract. That's 0. This is just x cubed, and that's plus 3x squared plus 7x plus 5, and then we'll repeat. Now when we look at our leading coefficient, x squared times what is x cubed? That's a single x. And we'll get x cubed plus 2x squared plus 5x, parentheses, subtract, and this is x squared plus 2x plus 5. Oh my. And then that will go in exactly one time. And this is x squared plus 2x plus 5, subtract 0. No remainder. So this polynomial f of x is equal to x squared plus 2x plus 5 times 2x squared plus x plus 1. And so now I've used long division to help me factor it by first taking both my conjugate pairs, using the factor theorem to generate this polynomial, and then doing long division with that polynomial. Now, let's see here. We already know how this one factors. This one factors as above. This one is quadratic. And so for 2x squared plus x plus 1, the zeros are x equals -1 plus or minus the square root of 1 squared minus 4 times 1, or 4 times 2 times 1, all over 2 times 2, which is -1 plus or minus the square root of 1 minus 8, yikes, over 4, which is -1/4 plus or minus the square root of -7 over 4, or -1/4 plus or minus root 7 over 4i. And those are my other zeros. And you'll notice that those also occur in conjugate pairs. And so the zeros were x equals -1 plus or minus 2i, I think. I can't remember now. It's been so long. Yeah, -1 plus or minus 2i, and -1/4 plus or minus root 7 over 4i, which means that f of x has the following factors: x plus 1 minus 2i, x plus 1 plus 2i, x plus 1/4 minus root 7 over 4i, and x plus 1/4 plus root 7 over 4i. And we almost got full credit on that, right? We took it home to Mom. We said, Mom, look how good we are. Put that on the fridge. And Mom snatches it out of our hands and rips it up and throws it in our face and says, no way I'm putting that on the fridge. Because the lead coefficient has to be 2. So watch out. Watch